How can we solve for x and y in this problem? Feel free to pause the video and check this question out. And after that, you can unpause it in order to see the solution. So first, let's understand some things. 2 raised to the power of x minus 2 raised to the power of y results in positive 2040 or 2040 for short. So what does this mean in essence? Let's focus on the left hand side. For we to have positive 2040, then 2 raised to the power of x must be greater than 2 raised to the power of y. Otherwise, the result will be negative. So if 2 raised to the power of x is greater than 2 raised to the power of y, then definitely x must be more than y as well. And if x is more than y, we can definitely replace x with y plus some number k that we don't know yet, which we are going to solve for. And what I'm going to do right now is just to replace this first equation as equation 1 and this one that we derived as equation 2. And I'm just going to substitute y plus k for x in equation 1. So let's do that and see what's going to happen. So equation 2, I would like to write it somewhere. So we can always use it as a reference whenever we need it. So therefore, in equation 1, we can have 2 raised to the power of y plus k, then minus 2 raised to the power of y to be equals to 2040. Now back to our knowledge in exponents. We know that 2 raised to the power of y plus k can be replaced with 2 raised to the power of y multiplied by 2 raised to the power of k. Then we have minus 2 raised to the power of y to be equals to 2040. If you are wondering how this turned to this, here's the reason why. In indices, if you have a raised to the power of b to be multiplying a raised to the power of c, you can typically select one base, which is a, and add those powers. Now this can be done in the vice versa way. If you have a raised to the power of y plus x, you can simply turn it to a raised to the power of y and multiply by a raised to the power of x. It's a law that we need to work with, and that's just it. So if that's the case, let's continue with our question. So right now I'm just going to factor out 2 raised to the power of y, since it is common in both sides. So I have 2 raised to the power of k minus 1 left over within the parentheses, and this is equals to 2040. So let's run a scan. What does this mean in essence? 2 raised to the power of y multiplied by 2 raised to the power of k minus 1. What does that mean? I want you to know that when 2 or an even number is raised to a positive integer, the result will always be an even number, regardless, as soon as the power is a positive integer. Now, if that is the case, what will 2 raised to the power of k minus 1, what will it become? As soon as k is also a positive integer, once we subtract 1 from the result, then we are going to have an odd number. And the good news is that both y and k are always going to be a positive integer, because the result we have here is a positive integer. So right now, we can finalize a conclusion. So which simply means all we need to do right now is to break 2040 into two numbers, such that the product of those two numbers will result in 2040s. And out of those two numbers, one will be even and the other will be an odd number. And the one that has to be an even has to be powers of two numbers. So what does that mean next sense? First, how can we get these numbers? And to do that, we can just use the prime factor method. So let's find all the prime factors of 2040. So I'm just going to have a table. On the left hand side, I will begin with the first prime number, which is 2. And at the right hand side, I will have what I wanted to reduce, which is 2040. 2040 divided by 2 is simply 1020. And 2 can still work. 1020 divided by 2, that's simply 510. Since 2 can still work, we can still repeat it again. 510 divided by 2, that's simply 255. At this point, 2 can no more work, but 3 in 255, that's simply 85. And similarly, 3 can no more work, but 5. 85 divided by 5, that should result in 17. And right now, nothing else can work rather than 17. And 17 is 17, that's simply 1. So which implies that all the prime factors of 2040 is simply 2 raised to the power of 3 multiplied by 3 multiplied by 5 then multiplied by 17. I think you should be able to figure that out. Now, we are having up to 4 different numbers we multiplying one another. That's not what we need. We need just 2 numbers that will result in 2040. Now, we said out of those numbers, we must have an even number. And that even number has to be a power of 2. So which means this is among our results. So 2 raised to the power of 3 is among what we need. Now, what about the second one? That's the one we need next, which is an odd number. So let's multiply 3, 5, and 70 together and see if we are going to have an odd number. We have 255. Since 255 is an odd number, then we have everything we need. So therefore, we are just going to replace 2040 with 2 raised to the power of 3 multiplied by 255. And right now we can have 2 raised to the power of y multiplied by 2 raised to the power of k, the minus 1 to be equals to 2 raised to the power of 3 multiplied by 255. Now, by comparing both sides, we can clearly see that 2 raised to the power of y is equal to 2 raised to the power of 3 since they are both evens, and 2 raised to the power of k minus 1 is equal to 2 raised to the 255 since they are both odd. So therefore, 2 raised to the power of y is equal to 2 raised to the power of 3. And finally, y will definitely be equal to 3. Once we use the definition of exponential equations, whenever the bases are the same, then their powers will also be the same. Now, what about the other part, which is 2 raised to the power of k minus 1 to be equals to 255? First, let's add 1 to both sides. We can clearly have 2 raised to the power of k minus 1 plus 1 to be equals to 255 plus 1. So at this point, the 1's can cancel out, and we can now have 2 raised to the power of k to be equals to 256. So at this point, what are we to do? So what powers of 2's will result in 256? It turns out that 2 raised to the power of 8 will result in 256. So we can just simply replace 256 with 2 raised to the power of 8. And therefore, let me get rid of this. We can now have 2 raised to the power of k to be equal to 2 raised to the power of 8. And applying the definition of exponential equations, k will simply be equals to 8. Now we have k and y. We can clearly get the value of x from equation 2. X equals y plus k. So therefore, x will simply be equals to 3 plus 8. And x will be equals to 11. And this is the values of x and y. X is 11 and y is equals to 3. So an exercise I have for you is that testify to this. Is x truly 11? Also, is y truly 3? For you to confirm that, plug in the value of x as 11 over here and the value of y as 3 and see if the result will be 2040. And that's it for this video. If you haven't subscribed, please do well to subscribe to my channel. Thanks for watching. See you guys in the next video. Bye for now.